Hi there! In this video we are going to learn how you can implement a custom metric in Evidently, and we're going to have a code practice. You know that sometimes to implement very useful and informative enough monitoring you need to come up with the custom metrics, but not all the systems give you the ability to implement it easily. In Evidently you can do that 100% and you can customize not only evaluations but the way how you want to visualize your metric, which is quite flexible. Let's take a look at the example. I already launched my Jupyter notebook so that you can see some code I prepared to you, and we will start from the importing libraries and Evidently components which we need to implement the examples. And then we are going to first discuss the logic behind the Evidently metrics, then see a very simple example, a dummy metric, and finally we are going to implement pretty complex metric ourselves. So let's start from the imports. You see that I always prefer to keep all my imports at the very beginning so that I can check that everything imported correctly. If you prefer to import things closer to the part of code where we use it, you can totally do that. I imported a couple of standard libraries like data class, pandas, plotly, because we are going to use it to implement our custom render, our custom visualization for the metric. Scikit-learn for a data set to play around with that, and some other things like typing. We also have quite a lot of components from Evidently. Some we're already well aware of, it's column mapping, report, right, and some new ones like input data, metric result, and we are going to explore them a little later. So that's all we need to run the example. Now let's briefly discuss and understand the structure of Evidently metrics and tests. I know that we haven't discussed the concept of tests before, but I'm going just to mention that tests actually exist. So the metrics. Metric is the key component of Evidently, right? Because every time we build a report, we specify which metrics we want to include to our report. Basically, we can see metric as the bunch of metric results. So that's the calculation which we need to perform and the results of calculations which we need to store in a specific format. So the result of metric calculation is stored in the metric result object. You can think of the dict with the different keys like the mean value, standard deviation value, maybe something for visualization, and its value, right? So it's somewhat similar to container where you store all the metrics evaluation results. Together with metric result, metric also have metric renderer. So basically that's the set of instructions which tells Evidently how exactly to visualize specific metrics. This metric renderer also depends on metric result because it doesn't calculate anything. It's basically derive the values from the metric result and build the visualization based on those values. This is why it's important to understand it from the very beginning, and when you design in your metric, you need to take into account that you need to calculate and save in the metric results not only values you are going to log, for example, to JSON, and build some conditional logic on top of this data, but also add some values you are going to use for visualization so that you can access those values from your render, right? That's how render and metric results are connected. We also have tests in Evidently, which are basically the metrics which we compare with specific thresholds, so that's metrics plus conditions. If you later will be interested into implementing the custom test, what you can do here is also think about what values you need to put in the metric results in order to visualize your test as well. Because tests have pretty different visualization, and maybe you will want to add some additional context or maybe reduce something compared to what you put in metric visualization in order to do debugging with help of tests, right? So when you design the metric, think of tests as well, and maybe after thinking about tests you will decide to add some additional values to metric results, or you can always return to it later and just expand your metric results. And finally, how tests are connected with metric results. Actually, test render is built on top of metric results because it also does not calculate anything, it just derives the values from test render. And well, test uses the data from metric results in order to see what is the metric value which test compares against some conditions. So that's the connection. I believe that's pretty straightforward if you spend quite some time into analyzing this picture, and well, we have all these things very well documented in Evidently. Now let's move to the second part of our video, which is dummy metric calculation. The idea here is take fairly simple metric and see how we can build our custom metric based on this simple calculation. In our case, it will be just summarization of the numerical value. And later, after we see how we can do that, we are going to implement more complex metric which is actually useful, right? So let's imagine that we just create a metric which summarizes the values of the numerical column. First of all, we need to define what is metric result, because we just discussed that it's a central component and we should start designing our metric from metric result. Well, in our case, it's pretty straightforward, as we're going to just summarize the value, right? And we can just add only one attribute here, which is some value. Let it be float, right? And I just want to attract your attention to the fact that we do not inherit my metric result from the object class, as we quite often do in Python, but we inherit it from metric result, which is basic metric result class from Evidently. All the basic classes we are going to use are already important, so it's metric result, metric, and many more, like metric renderer. So here we are. Let's run this piece of code. Okay, got it. And now, after we implemented metric result, we can move and implement our metric itself, right? For doing that, we need to inherit my metric from the basic metric from Evidently and pass the my metric results here, right? Because my metric heavily depends on metric results. We also need to come up with the structure of metric class. And here we need to add the attribute column name, because actually we calculate this metric on the column level. So we need to have a way to put the name of the column to our metric so that we understand which column to summarize, right? So that's what we did here. Also, we need to implement the init method, which is basically constructor, right? And here we have a self, of course, and this column name string, right? So what we do here, we initiate this column name variable with the string value, and we also use the constructor from the base class, right? With help of super, we call this init method. And finally, we need to implement the calculation method, because we need to let Evidently understand how exactly to process input data in order to fill all the fields from the metric result. In our case, it's just a single field, some value. So we need to pass the input data here, because we calculate those results on top of the input data, and we return my metric result. That's what's written here. So in order to calculate it, let's say we use only current data, right? So we put the column name here and just use method sum, so it's really dummy metric just for the educational purpose, and we return my metric result filled with the calculated value. Well, that's it. So let's run it. And I would like to draw your attention to the fact that you can customize not only way how you calculate metric, but also how you render it, and not only for HTML, but also for JSON. JSON is great for a storing way, right? If you need to store your data long term, I mean store your calculated metrics for quite a long period of time, JSON is a good solution, right? So let us do that. And I would start from the JSON render. So first of all, I want to say that we have a quite nice wrapper, default render, so we can wrap our class with that, and wrap type will be my metric, because that's the renderer for my metric. Now let's implement the renderer class, which is inherit from Evidently metric render, right? That's the basic class for renderers, and we need to implement two methods, render JSON and render HTML. We need to pass here self, of course, our metric, in our case it's my metric, and we have some additional data for JSON, which we use in the standard JSON renderers for Evidently. Basically, this is very helpful if you have quite complex metric result structure and you want to let your users to specify which part of metric results to include inside of your JSON, which exclude from your JSON, and actually maybe you can want to do some automation here. For instance, include renderer. These are all the data which are marked are data for visualization, data for render, and for instance, if you have quite complex visualization, which includes a lot of different values, parameters, you can just exclude it from the JSON if you don't want to store it for the long period of time, right? If you just want to include in the JSON render only data related to the metric calculation itself. But I believe that's additional details which you can get from our documentation if you're really interested in the metric customization and implementation custom metrics. So now that's it, and basically here I'm not doing anything really complex. I just get my result from the object, right, which is my metric. So I just get metric results and I transform it to a dict. This is Python dictionary, which I can easily transform to a JSON, so basically that's it. Then let us implement renderer HTML method, where we pass self and my metric, right? And we are returning list of base widget info. This is quite internal, evidently component, so I'm not going to really spend quite a lot of your time into discussing that. And if you're interested, I suggest you to go to evidently official documentation. So here what we are doing is we again derive calculated metric result with help of getResult method, right? And here we need to return some base widget info, which is basically a visualization component from evidently. Luckily, we have a lot of helper functions for visualization, and you do not have to implement anything custom if you do not want to. So if you just want to visualize your metric result as the metric name and metric value, for instance, you can go for header text helper. In this case, you just need to pass the text which you are going to show inside of your report, right? In my case, it will be my metrics value is and the value of sum, right? And that's it. I would suggest you to explore more options for helper functions for visualization from Evidently, right? It's all available at Evidently Renderers HTML widgets. So feel free to take a look and see, maybe you will like something else. And here I finished the implementation of my dummy metric. Let me run this code. And now let's try to see how this looks like inside of Evidently report. For doing that, I would need to have a dataset to play around with, and I'm going to use the scikit-learn datasets module for doing that. I will use fetch OpenML function and the adult dataset. That's the dataset we used before, so let me just load it, and I'm going to transform it to a data frame format. Future warnings as usual. And now let us build Evidently report. So as I mentioned, I already imported all the pieces of Evidently which I need to use here. So I also imported report before at the very beginning, so I can now create the object. And in metrics, I can pass my custom metric, which is my metric. And you can see that syntax is very similar to what we used before. So if you import any standard Evidently metric, the syntax will be very similar. So let me do that. That's my metric, and I pass the column name, which is equal to age. Basically, that's the only column I remember from adult dataset. And let us run the calculation. I pass only one data frame as a current, and I'm going to show the result right here inside of Jupyter Notebook. And that's it. So you see that it was fairly simple to implement a dummy metric inside of Evidently, and that's the render. Also, you might be interested in how it looks in the JSON, so let me just call it, and you can see that, well, fairly simple. That's the Evidently version, some meta information right, and the results, basically. So now we know how the scheme works, and now let us implement more complicated metric. I suggest us go for some metrics calculated by different categories, because sometimes it's very important to not just analyze the metric on top of the whole data we have, but to split our data into specific categories, for instance by some category variable, and calculate any descriptive statistics individually for each category. Let us implement mean value by category metric and see how we can do it inside of Evidently. I just added new title, and let us create the class for this metric. I will start from the metric result, of course. I started from the most obvious things because I'm going to calculate column mean value by categories, so I need to have information about what column I use and what column I used as the category. And let me think through the visualization because I'm going to add some additional context for the analyst so that he or she can understand what's going on with the data visually. I suggest us to simply create a bar plot where we will have the mean value for each category, right? This is mean that I need to store the values for this bar plot. Let me store the values for x-axis and for y-axis for both reference and current data. Let me add it to my metric result class as the additional attributes. I believe that's enough and I can proceed to my metric implementation, but before, let me think through the following scenario. What if the user will pass only the current data for the evidently, because that's what evidently allows us to do. In this case, if I just leave it like this, I will have an issue with the reference x values and reference y values because it's just not here, it's not presented. How to fix that? Let me mark to these components as optional ones. Now, if I will not receive those values, it will be no issues with that. Let us proceed with metric class implementation. The structure of my class is ready because in order to calculate my metric, I need a user to let me know what column to use for mean calculation and what column to use as the category. Now let's proceed with init and calculate methods implementation. And please do not forget about the init from the base class. Here it is. Now let's implement the way how we calculate those values. For doing that, I'm going to use pandas, group by, and aggregate functionality because I'm going to group by my values by category column and implement and calculate mean for each value. So let's do that. So I return column mean by category result because that's the idea of method calculate, right? I need to fill all the values from column mean by category result. And now let us fill those values. Let us quickly stop here and take a look at what we just implemented. We know that reference data is actually optional in most evidently metrics, so let us follow the same logic here. And first of all, I check if reference data is actually presented in data, and data is the example of input data class, so you can explore the structure of input data class from evidently in more details if you wish, but the important to understand that there are reference parts and the current part of data inside of the input data object, right? So first I check that the reference data is not none, and if it's not none, I calculate all the needed statistics. In my case, it's just aggregated mean by the category name, right, by category column. And my current data should be presented, right? So next, I calculate the needed statistics by current data without any if statement. Now let's calculate data for visualization, because we also need to calculate x and y values for current and reference data set. It should be fairly simple. Well, that's it, and you can see that I check for my reference data again and again if it actually exists, right, in order to avoid any issues with non-existent data calculations. And finally, I need to return the column mean by value category result, right? So let me do that. The best way to implement it is to check again what you actually passed here and just make sure that you filled all the values. Well, looks like that's it. Now let's implement our custom renderer and we will be able to see whether we implemented all correctly, maybe do some debugging and finally run our metric in Evidently report. Here we have our render, and you can see that I decided to keep it very same to what we had to our dummy metric. So the idea is that we just collect all the data we had in our metric result, right, and dump into JSON. That's the idea. So I could easily just copy the method from my dummy metric actually. And now let's implement the HTML render, and here I want to add some customization because I want to implement a bar where we will have the values of mean by y, right, and the category names by x values. So let me do that. Well, looks like that's it. Now let's try to do some debugging and see whether we implemented everything correctly. And well, now I see that actually we could implement this render HTML a little bit like more compact without repeating some instructions, but let us consider it as your homework because I'm trying to do it right now. So let's run and see whether it works. And in order to fully understand whether it works or not, we need to come up with the report and see how exactly we implemented those renders by running the following command, show and JSON. So let's do that. I'm going to reuse the adult data frame, which we already have in memory. So let us create a report. Now, instead of dummy metric, I'm going to use my column mean by category metric. So I'm just copying the name here. And I need to specify both column name and category name so that my data will be calculated for a specific column by specific category. And well, let me have the age as the column name. That's probably my favorite column for some reason, probably because it's just had a short name. And category. Yeah, so let's pick some categorical feature or education. Okay, it works for me. Now let's run the calculations. Let me split it just first 100, let's say, or 1000 rows. And let's check. Okay, of course. Yeah, now let's see how it looks like. Some future warning, my favorite part. And that's the visualization. So it looks exactly as we expected, right? So this is the title, age column mean by category education. And you can see the plot for our current data, it's written here, and for our reference data. So we can compare and analyze the mean for each education category between reference and current data and see that they are quite different actually. And let us finally check the JSON. Or maybe first check whether it works for a single data frame. Yep, so we have the full-sized picture for only one data frame. And let me just try to get my JSON data. So it's report JSON. Let's see. Something is wrong with our JSON. Let me quickly get what is wrong. Okay, I misspelled object. Okay, going back to the following method. Try not to be too upset about it. Well, now should be better. Let's try it once again. Yeah, I need to actually rebuild the whole method. So let me rebuild that. Yeah, finally works. And we can see that the JSON looks exactly as we planned, right? Because we have all the data from the metric results right here. So that's values, name, category name, X values, Y values from current, and same from the reference, right? Well, we would have same from reference if you would have reference. In our case, it's just a null, right? But anyway, you have those data. Basically, that's all I wanted to share with you in this particular code practice. So now I believe you have a good picture of how to build a custom metric with Evidently, which you can later integrate into any reports, right, or use for logging or for monitoring as well, right? So I hope it makes sense. And well, if you believe that you have in mind a metric which Evidently library can benefit from, just remember it's open source and you can always implement it and send a pull request to us. We will be happy to receive it.